Hi everyone. So today we are going to see our project of big data, CSCE 5300. Our title is custom email classifier. We are of group one. So where myself and my friend Nagavenkata Kanakalakshmi. So we both are going to present this particular project. And next agenda. So today we will be going to see the introduction and the problem statement and hypothesis and goals and objectives till the conclusion and references. So in middle we will be discussing about the integration of big data and data sciences and exploratory data analysis as well. And coming to the introduction, so as we already discussed about what exactly our title mean, like our title is like custom email classifier. So where we are trying to categorize or classify the emails. So what is exactly an email? So I think it's a pretty straightforward thing, right? So email is a short electronic email that will be like a form of communication that happens between a person to person, and moreover it is like it's a high level thing that will be going on between in day-to-day business life, wherever the people communicate between themselves, between the clients, employees, and everything. And also, it is serving as a platform for project coordinations and everything. And moreover, email serves as an efficient way to provide the customer support and assistance. So I think that's a short introduction for email. So let's quickly jump into what exactly we will be dealing in this particular the project. So the problem statement is like due to the distillation, of course. So we are in 21st century, and the distillation is at it peaks. So as the distillation is going on, like it will be where the data is growing day by day, and the data is overloaded in each and every communication system or any field. So here the problem is we will be having overloaded information where the large volumes of the data is in forms of the emails and that hitting your inbox. And next will be like if you want to deal with those large amount of the data, so definitely the productivity will be diminished. So, and moreover, the main thing, we have the problem of spam, isn't it? So in this, actually, there is a quote saying that spamming and distillation are directly proportional to each other. Where in the present day, so as distillation is growing, the spamming also increases. So we need to come out of this particular spamming techniques and everything. And moreover, the customization. So where the customization definitely need to be everyone needs customization, because someone thinks it as spam and someone doesn't. So in that particular manner, like we also need to have the insights. So these are all the problems that we will be addressing as part of this particular project. And let's see the hypothesis. So when we manually categorize the things, manually in the sense, if we do manually by the user itself. So definitely, as the data is very huge, so definitely it will be like we will be taking a lot of time to consume to categorize the emails, and needs to be done daily to classify the emails, and which will be hectic task. And misclassification of the spam definitely can occur. A user cannot go over the previous spam email and find the patterns, isn't it? So it's very hectic for the manual categorization of the emails. So now let's see a plan that we will be automating the process of categorization using regular technologies. So for example, if we want to store the data set as part of these SQL, maybe we can employ some rule-based systems. So where rules are stored in traditional databases, which are like predefined, and moreover, we can famous matching keyword techniques. So where we will be creating the rules based on the specific keywords, where it will be present with email subject, body, and sender information. And moreover, we'll have the filtering on center based, definitely. So this is the famous feature that is offering by each and every email client nowadays, and there are many more. And I think with that particular regular technologies, definitely we'll have some problems as well. So here are the list of problems that we'll be getting with automation of the regular technologies. So generally, data sets are like heavily unstructured, isn't it? So nowadays, like there are three types of data. Like one is structured data, unstructured data, and semi-structured data. So as part of the recent study, like unstructured data is almost 99%, and moreover, like at 1% is spanned for this semi-structured and structured. So most probably the unstructured data definitely will be present as part of the text, isn't it? So definitely SQL can't process the text files, isn't it? So we can't directly process them in the SQL database, because it's purely relational. And as data is generated day by day, and definitely normal databases can't be stored and handle them. And moreover, the rule-based systems. So rule-based system has its own drawbacks, saying that it has limited adaptability and inability to learn, because they are like predefined. That's it, and they are kind of metadata. So and handling complex problems and scalability. And moreover, matching the keywords will definitely fail if the keywords are like ambiguous or context dependent. So and the center based filtering may lead to misclassification if senders are like spoofed. And let's see what exactly the automation we can do with the big data and data science, because these are the cutting edge technologies right away. So we are using we can use the latest data technologies like Hadoop to store the big data, so where it is well able to continue the things, and Spark, so to process the data in the flashing time, and Spark SQL to analyze the things, and many more data visualization tools and etc. So now let's see the goals and objectives of our particular project. So if you can see the motivation, so I think we have already gone through the issues and that will be concerned for this email communication. But to on an overview, here our motivation is to address all the issues like the custom email classifier will be one-stop solution, definitely to customize the dataset and everything, and to provide the extreme personalization to required by the users and increases productivity for the individuals. And moreover, like we wanted to use like cutting edge technologies, so where we'll be producing out an effective and efficient and cost effective solution for both analytics and analysis. And let me talk about some spam emails, because this is the nowadays a burning problem. So these are like I think more probably these are unsolicited and irrelevant messages sent to the bulk of a large number of recipients via email, and it will be like mostly promotional intent. And these are the examples of some of the examples of the spam emails, and challenges of the email classification. So here we have the four challenges definitely. So definitely by day the email formats are changing, and moreover spammers are like going out with misspellings and informal languages, so that to get out of the track of these particular detection systems. And moreover we have the imbalance systems where we have large number of spam which will be affecting the training data sets and everything. And coming to the significance of this particular project, what is the importance of this particular project? So custom email classifier is important because it is a solution for getting out the custom, flexible, and customized way of organizing data. And moreover, the project is capable of handling the multi-category classifications like spam, not spam, and suspicious. And moreover, it provides utmost customization. And moreover, it's consistent classification. We have used many machine learning, top-notch machine learning algorithms to make sure that whatever the prediction that is done is correct. So coming to the background, so as part of the background, so there are we will be seeing some of the related work that has been done previously. So as part of there, we already have some email filtering systems like Google's Gmail, Outlook, and Yahoo Mail already. So they have implemented the rule-based filtering and spam detection algorithms. But as we already discussed, it is rule-based and everything are predefined, and sender reputation and definitely content analysis will be gone. And next will be custom email filters. So these are like created by the users itself, which will be provided by the recent clients. But they can't. I mean, they are limited to the things, whatever the features they have provided. And we have some AI-driven project tools, but they are not into the up to matured. And what exactly uniqueness of this particular project we are going to see? So as we already told that we are combining so both the big data and data science, where we'll be using the Hadoop for the storage, and maybe Amazon S3 or other big data technology for storing the data. And we will be using Spark to fasten the processing as soon as possible, so that we are using largely capable database, and we'll be processing the Spark as soon as possible. And spam email communication will be performed correctly, as we detecting spam email patterns based on the user preferences, and it is fully customized. And moreover, as we already discussed, it's cost effective, because we are using both the things, and we are making sure that everything is cost effective for everything. And coming to the objectives, the straightaway objectives are we wanted to make scalable and customizable email classification for the users. And moreover, the productivity of the individuals will be definitely increased due to this particular tool. And moreover, this is an integration of cutting edge technologies such as Spark and kind of Hadoop. And moreover, there are other things like we are using the Spark ML Lab, which will be heavy machine learning algorithm library nowadays. And next list is like we will be using various data visualization tools for analyzing the data, which will be giving the insights for the user where they can use directly. And moreover, we have gone through with special ML libraries, I mean algorithms like naive Bayes, decision tree, and random forest, and etc. But which will be giving a heavy kind of performance metrics, and we got the best out of them. And coming to the methodology, yeah. So from here, Lakshmi will continue.
Yeah, hi, this is Nagavenkata Kanakalakshmi. And here is the architecture diagram as part of the project. We have used the many technologies such as the Hadoop, Amazon AWS, Spark, and MLlib of the Spark. And we have loaded the dataset into the Hadoop HDFS, and we even saved the dataset into the Amazon S3. And we process the data from the Spark. And after loading the dataset into the Spark, we have performed the Spark SQL queries. And once the Spark SQL queries are done, we even visualize the data using the matplotlib libraries and the seaborn library. And once the data visualization is done, we have made the data pre-processing by imputing the null values with the mean of the data and perform the scaling using the min-max scaler technique. And once the scaling is done, here we our data set is ready to compute and train the model. And by using the Spark MLlib, we have performed the exploratory data analysis. And once exploratory data analysis is done, as part of a project, we use the naive-Bayes multinomial, naive-Bayes Gaussian, and the decision tree for our project. We have trained all the models and performed the cross validation and performed evaluation, and we found the best models. And once after the best model is found, we made the predictions and perform the performance metrics is evaluated. So this is a combination of the big data and data science. Next. Here is the data flow diagram, and initially we collected the data and loaded the data into the Hadoop and S3, and we fetched the data into the Spark. And we performed the Spark SQL queries and performed the data pre-processing using handling the null values and performing the min-max scaling. And then once the scaling is done, we perform the exploratory data analysis. And after the data set is done, and we have split the data into the features and the target data, and we use this naive Bayes and the decision tree as part of the project. We train the model. Once the training is done, we perform the cross validation to find the best results, and we even tested the models and model evaluation. And then we plotted the performance metrics of the best results and without the hyperparameters too. And the next slide will be explained by Karthik.
Yeah. So let's dive into the architecture models that we are be using for this particular project. So as we already discussed, we will be using famous Navies and decision tree as part of this particular project. So as we already know, what exactly the architecture mean of these Navies, because in Navies, one famous thing is all the the features are independent to each other, so nothing will be depending on one on another. And the outputs of this particular naive Bayes is this will be classifier outputs a probability of each class label, and the class label with the highest probability is the data point that is classified as. And moreover, the training is done on the sets of the labeled data points, and the training process involves estimating the probability of each feature for each class. And moreover, the classification is done on the naive Bayes classifier, can be used for classifying new data points by calculating the probability of the each class label, and will get the class with the highest probability. So this is for the naive Bayes. And coming to the decision tree, so it's a directly straightforward architecture. So where this is a form of a tree. So where we'll be inputting all the set of features that have been describing in data point, and the outputs will be definitely the classification that has been decided for that particular data row. And the training will be done on the label dataset, and the training process involves recursive of partitioning of the data, definitely, because partitioning happens for the trees, isn't it? So on the left and right. So if at all, if you see this one with friends, it will be, if at all it is yes, it will be windy, and if no, then it will be taking care of walk or cart. And then if at all it is windy, they'll check it out whether it is yes or no. If at all it is yes, above par. And then if at all it is no, it is cold. So in that way, it's a conditional way of classifying the things. So this is the basic architecture principles of decision tree and the naive Bayes. And next, as we already discussed about the big data technologies that we are going to use, so this is the Hadoop architecture, high level Hadoop architecture diagram, whatever the technology we are going to use in this particular project. So if you can see this, Hadoop is not a single technology, it's a kind of a family, or it's an umbrella of the technologies, which includes HDFS, MapReduce, Hive, HBase, Pig, OZ, and Mahout, etc. So where it all combinedly called as Hadoop. And this is a Java based technology that has been used, and which will be helpful for storing all the big data and processing it. And next will be definitely the Spark. It's a famous one and it's a hero of nowadays. And because it has been processing the data like more faster than the Hadoop, and moreover, Spark has an integration capability of these are all the technologies. I mean, these are all like for the namesake, like we have kept here, but there are many more that I can integrate with the Apache Spark. And this is the high-level diagram, architecture diagram for the Spark, where the cluster manager has these worker nodes and where each executor has task, cache, and task, and then it will be find out by the driver program, and the Spark context has the data that needs to be dealt. So this is the high level of this Spark architecture. So let's deep dive into dataset. Lakshmi will take care of here. Take over.
Yeah. Our email dataset consists of total of the 5,172 records and around the 3002 columns. And the first column is about the email name of the dataset, and the last column is about the target data. And we have the target data of the three categories, such as the spam, non-spam, and the suspicious. And excluding the first and the last column, we have the around of 3000 features, which is about the frequency of the words. And coming to the loading of the data, we have loaded the data complete using the Spark session, and we even displayed the a few records of the data using the show function. So here is the features and the label design of the data. Completely, it is of the three target categories of the data, as we already discussed. That is the spam, non-spam, and the suspicious. And we have the frequency of words around 3000 words. So now, as part of the project, we have integrated the Hadoop with the Spark. So initially, we have set up the Hadoop in the AWS in the EC2 instance. And we initially has launched the Ubuntu server instances in the AWS EC2, and with the T2 micro instances chosen for the demonstration purpose. And after launching the instances, we have named it as the name node and the data node for the easier identification. And we even set up all the required software installations, and we even upgraded the OS as part of the project. So once the installations are done, we have configured all the Hadoop required libraries and the configuration files in the code site.xml, and all related to yarn, MapReduce, and everything. And once it is done, we even created the master and the slave procedure. After that, we have we have even named the name node and the data node, and we even updated the configurations in both the name node and the data node, and we even generated the key gen to map the name node and the data node. And once the configuration is done, we even have the web UI to access whether the Hadoop is running or not. And once after the Hadoop is started, we uploaded the CSV file using the HDFS commands. And once after the file is loaded, we can even see the loaded file in the web UI. That will be shown in the future. And once after the data is loaded into the Hadoop HDFS, we have accessed the file from the Google Colab using the domain name and the path, and domain name and the path. So here are the few code snippets. How do we copy the file to the Hadoop HDFS? And we use the commands such as the Hadoop HDFS copy from the local, and to the location where it is required. Once after the file is copied, here is the visualization. We can see that in the view we have uploaded the emails.csv, and the dummy emails.csv is a test file. And once a file is loaded into the Hadoop HDFS from the Google Colab, using the domain name and the port number and the path of the file, we have loaded it to the Google Colab, and we read the file. So from here, Karthik will be continuing.
Yeah. So coming to the integration of the Cassandra with Spark. So as time is constrained, like so let me wind up soon. So integration of the Cassandra with Spark. So we have directly installed whatever that has been thought as part of the activity. So we have opened this cloud Amazon Cloud Shell, and we have created all the instances. I mean, we have downloaded the Cassandra, and we have made that particular thing up. And Next, we have created a table as part of it, and which is named as email dataset, and we have all the features of it, and we have like 3,000 columns out of it. And next, we have accessed that part. I mean, we tried to access it from the Cassandra table in the Google Colab with using this particular library. So where we need to download and install the Cassandra driver, and we need to pass the instance of the EC2 as the domain and the public IP of that. And my key space, I have just kept a dummy key space called yours key space, and I'm trying to create a key space of over here as part of this accessing this Cassandra. And coming to the next integration with the big data, so integration of Amazon S3 with Spark. So S3 is also a part of a big data because it has a data lake where the large amount of data will be stored as part of it. And mostly to access that particular S3, so Amazon has a lot of restrictions where we need to create access key and secret key from the Amazon console. And for the particular access key and secret key should have the access of S3 all access permission. If at all that was given, and if we can access this access key and secret key, then done. So we can access the S3 that has been configured. So this is the library that we used to connect to the Amazon S3, which is called Poto. So where we have installed this particular thing. And next, this is the integration code of this. I mean, integrating with Amazon S3. So where we need to give the bucket name, file name, and next access key and the security key, and then we need to pass that particular key as part of this S3 download file, where the file will be downloaded, and that will be used whatever we can do for next from then. And coming to the exploratory data analysis, Lakshmi will continue. Lakshmi, you are mute.
Yeah, 1 second, I'll just plug my charger.
Please unmute.
Yeah, exploratory data analysis is a crucial step of the, perform the patterns of the data set, and it also helps to gain the insights, identify the trends and the data set of the anomalies. And it also helps to, define the features of the data like spam, non-spam, and the suspicious of the data. And we even distributed the data into the spam, non-spam, and the suspicious, and we use the word frequency analysis, which helps the highest to find the highest number of words used in the email. So coming to the next slide, here is a code snippet of the data. Like we used, so all the target data, and just go ahead. So yeah, here is the pie chart visualization where the 27% is of the spam data, and the 5.9% of the suspicious data, and the 66.7 is about the non-spam data. Yeah, here is the code snippet for the word cloud, and we have found the highest frequency of word. Yeah, here is the visualization. Like we can see that the meter is the highest frequency word, then the deal, then known, then need, in that way. And data pre-processing. Data pre-processing is one of the major technique to handle the null values in the data, and to make the if any of the data is not properly maintained, we can maintain using the data pre-processing techniques. So why data pre-processing is used? The data pre-processing, it is majorly used to remove the null values and impute the data instead of null values. It helps for the performance of the model. So general steps in the pre-processing we use is handling the null values, scaling of the data, outlier treatment, and the feature encoding and dimensionality reduction. And as part of our project, we have used the two techniques such as handling the missing values and the feature scaling. So handling the missing values. Here is just a code snippet. We can see in this snippet, we don't have the any null values in the data. So we can see all the values are null values are 0 in all the columns. And the feature scaling. So min-max is the best scaling for the data set, and it always ranges the value from 0 to 1. So it uses the best performance to the model. The code performs data visualization before the if you perform the scaling before the data visual before the training the model, it's a good technique of the data modeling. And here is the visualization before scaling the data. And then here is the scaling after performing the scaling, and we can observe that all the data ranges is from 0 to 1. So Spark SQL. Spark SQL is a concept of Apache Spark that provides a programming interface for structured and semi-structured data in the SQL. It is used to help the query the data over the large data, and we can use either the SQL commands and or the data frame API. So here is this just a code snippet, and we have performed few queries. The first query is like we have find the email number which has the highest frequency of the word Yahoo, and what is the corresponding frequency value. So in our data set, we have found the highest frequency of the word Yahoo, and what is the count of it by the specific email. And the second query is find the word mostly used by the email 99. Email 99 has used the word the in the data set. I mean, like in his email. Yeah, we can see the output over there. And query 3 is like finding the email the term amazing is used anywhere. Yes, we have seen that sorry, awesome anywhere. We can see that the email has many of the email has used the word. So query 4, find the email number who has used the com word more than 10 times in their email content. So most of the emails, they use the word com in their in the content. So many of the emails have used the word com in their content more than 10 times. And the fifth query is like find the columns which contains the com in the column except the primary column. We are excluding the first column, it's input data, and rest we are considering all the columns which has the com word in the feature. And next query, find the name column names which are starting with A except the primary column. So we are just computing the column names which are starting with A, such as A and at R, etc. And get the email number which are not forwarded direct. So by considering the few terms in the data set, we are considering the they are not forwarded
Lakshmi,
by someone's.
yeah, I think we are going beyond 30 minutes, so let's wind up
Yeah,
quickly.
yeah.
So yeah.
So this is the query. Yeah. And the query it is about the get the email number who has attached the Excel sheets of the email. Like we'll know the Excel sheets who has attached. So what is the average count of using word A over the 5,000 plus emails? It's around 55. It's around 55 plus highest word frequency. Yeah. And the final query is the select the columns with the frequency greater than 10. So here we are finding the email number with the each and every column which has the frequency higher than 10, and they printed the respect to all column data. So splitting of the data here, the splitting, we have divided the data into 70% for the training and the 30% for the testing. So it will be we have the train data and the test data, and the implementation will be taken care by the Karthik.
Yeah. So as time we are already running out of the time of 30 minutes, but yeah, I'll try to quickly wind up the things. So algorithms available are the models. There are like many models like support SVMs, naive Bayes, and decision trees, and logistic regression, and artificial neural networks, and many more. But we have only selected naive Bayes and decision tree for now due to the time limit and the project scope. So coming to the naive Bayes, there are like as we already discussed what exactly the naive Bayes is. So the fundamental principle is the probability theory in it, and we'll be having very independent things within the features. And there are three types of the naive Bayes. One is Gaussian, multinomial, and Bernoulli. So Gaussian is will work very good on the continuous data, and multinomial for the multiple categories, and Bernoulli is for only the binary data. And coming to why naive Bayes. So as we already said that it's very simple, and it is based on the mathematical prediction model. And naive Bayes is very scalable, and naive Bayes is robust to the noise because no feature is dependent on the other feature. And coming to the decision tree, definitely decision trees are like supervised. They are like supervised machine learning algorithms, and they follow all the tree-like structures, and recursively they divide the data set into the subsets based on the values of the input features. And moreover, the terminal nodes will be the final classification of the particular model. And it also utilizes the splitting criteria such as like gene impurities or entropy models to classify the things. And coming to wide decision tree, decision trees offer definitely the transparency, aiding on users in understanding and interpreting the classification decisions. And moreover, it is versatile in managing both the numerical and the categorical data, which is very good. And naturally, it is a tree, so definitely it will be giving a best classification results. So coming to the libraries used, we have used Navies. I mean, we have used Spark ML, which is a major library that we are relying on the for the machine learning. So as part of this Spark PySpark ML classification, so there is a Navies class over there, and we have used the multi-class classifier evaluator and parameter builder and cross validator for tuning the hyperparameters. And we have used the matplotlib and Seaborn for plotting the data visualization libraries. And coming to the base data structure, so this is the base data structure where we'll be storing the six models that we are going to develop. And coming to the naive Bayes implementation, so this is the snippet for the naive Bayes multinomial model. So where we have created the instance of naive Bayes, and then we simply use the fit method to train the data, and then transform method to predict the values. And this is the code snippet for displaying the accuracy, precision, and recall and F1 score. And this is the plotting results of this particular naive Bayes. So where the accuracy stands at 88.49%, and the other rest are we can see over here. And coming to the naive Bayes, next is naive Bayes multinomial model with the hyperparameters. So where we have tuned the hyperparameters using the smoothing, where we have given 0.4, 0.6, and 1 as the smoothing parameters. And this is the code for printing the accuracy, precision, and recall and F1 score after tuning the hyperparameters. And maybe you can see the best scores after hyperparameters. If you can see, the accuracy has been increased to 88.56, which is good, and the best smoothing algorithm, I mean, smoothing value can be seen over here. And coming to the next model, like naive Bayes Gaussian model, where this is the code snippet for performing the naive Bayes Gaussian model, where it is the same as the before, and where the fit and transform methods are used to just train and transform. And next, we have used the Gaussian model and to print all the accuracy, precision, and recall and F1 score. And coming to the plotting results, we have these are the results for this particular Gaussian. As this is an classification thing, and there is no running amount of the data, we have only the frequencies, so Gaussian doesn't perform well in this particular data set. And coming to hyperparameter tuning, definitely we have used hyperparameters for building it well and running it well, but after that also I think it doesn't show very well. So these are the code for building out the parameters, and these are the accuracies. There is no still changes in this particular thing. So the best Gaussian smoothing will be 0.4. So yeah, the decision tree will be continued by Lakshmi.
Yeah, I discussed already by the Karthik regarding the decision tree architecture. Now we have we'll go through the implementation part. We just created the instance of the decision tree classifier with a label of the prediction class and the features with the scale numerical features, and we just train the model and make the predictions over the data. So yeah, here is the performance of the data, like accuracy, precision, recall, FN score, and we just printed the evaluation metrics, and we even next visualize the data. Here is the visualization of the metrics, like 80% of the accuracies and 79% of the precision and recall and FN score. Yeah, and we use the different hyperparameters to find the best model using the different hyperparameters with the max depth of 6, 10, 12 and the max bins of 16 and 32. We use the Gini impurity, and we perform the we use the multi-class evaluator and perform the cross validation over the different hyperparameters and found the best results over it. So here we can see the best results over it. Best accuracy is of 85% and 84% of the precision, 85% of the recall, and 85% of the F1 score. So here is a visualization of the data, and the best hyperparams with a depth of 12 and max means of 32, and the impurity is Gini. So the results will be taken care by the Karthik.
Yeah, so coming to the results, definitely we already discussed about accuracy, precision, and recall and F1 score. These are like basic definitions of these of them, and we already have printed some of them as part of the previous implementations. And coming to the best model, definitely the name is multinomial is the superior for email classification with the three categories because its best works for the discrete amount of the data and count based features. So particularly it works on the features, and you can see all the naive base with the hyperparameter tuning and without hyperparameter tuning accuracies and other performance metrics over here. And coming to the decision tree, you can find over here. So out of these things, multinomial has beaten everyone. And coming, this is the whole graph that we can see with all the grouped, performance metrics of all the models. So 6 models. So if you can see clearly, multinomial with hyperparameters has topped the things. And coming to the project management, so we have equally divided the work between Lakshmi and myself, and we both worked on exploratory data analysis and data pre-processing. And I have worked on Airways models, and she has worked on decision trees. And then we have gone with this data visualization part. And for the coming to the integration part, she has worked on particularly on Hadoop integration with the Spark, which is a larger thing. And I have worked on S3 and Cassandra. And yeah, we have faced some of the issues actually. The integration whatever we have done, so at the 99 we have came up with 99%, but we have lost at 1%. So where by looking at this particular thing, dead nodes, so there is an issue called dead nodes as part of this particular thing. And we also next we have tried with the Cassandra, but Amazon cloud is shell, we can't expose the external URL to process the tables outside. And moreover, we have tried in EMR, but we have landed in out of memory issue. And coming, we will also see the issues whatever we have faced soon after this particular PPT. And there was a feedback that was addressed, I mean, came up in the proposal. So the comment was like how you will improve the results of the spam detection and other email classifications. So yeah, so that will be addressed using the hyperparameter tuning. So we have done like hyperparameter tuning using all the cross validators, evaluators, and everything. So where the results of spam detection will be definitely increased. And we have used analysis for analysis. We have used the Spark SQL and MLlib integration, and where you can it leverages the power of the SQL and MLlib together to increase the results of this spam detection. And we have done the proper data processing using the scaling min-max scaler, so where the data noises will be reduced. So conclusion, coming to the conclusion, definitely. So this email classification will be a custom one, and it can be a boon for everybody. And out of this, all the models that we have used, the multinomial has topped it, and it has the best accuracy out of it. And coming to the references, so these are the references and the emails, the links that we have gone through. And let's quickly go through the results and walk through. Yeah, so this is the code file where we will have all the flow over here where you can find out whatever we have submitted. And the other thing I wanted to show is this is what the PDF we will also submit for Hadoop installation on AWS. So where we have installed, and I'll as time is limited, so I'll quickly jump into the last slide where we are facing the issues. So once if you can see here, once if you can clearly see, we have installed successfully the Hadoop cluster, and we have hosted over here. And we have opened this web UI of Hadoop, whatever the Lakshmi has mentioned. And if you can see here, after data has been inserted into Hadoop, so we can clearly see these emails.csv in the Hadoop, and you can see over here this is the Amazon EC2 public URI. Almost 99% was done, and it was clearly exposed to external world using the security groups and everything. But we have facing an issue of this task 0 in the stage 3 failed one items because of it is saying that there is no live nodes present as part of thing, but we are still researching it. Instead of that, we have gone through instead of the Spark and Cassandra, we have leveraged the integration of S3, where we have connected to This is the code as we already seen. Like we have connected to S3 and we have downloaded the file. I mean, we have got the access to email.csv and we have directly processing it in Spark. In this way, we are not storing the data as part of the Spark, and we are storing in S3, where S3 has some greater cost effectiveness nature, and we are making the whole project by using S3 as well. It is cost effective and top notch application. So by this, I wanted to conclude. Yeah. So we'll place on video presentation link over here. Yeah. Yeah. Thank you. Thank you for your time.
Yeah, thank you.